This is lecture 3, called One-Dimensional Delta Wells. It's part of a mathematical physics course on quantum mechanics at senior level, and the first author of the text using for this course, this lecture set, is Davies. Here's the text. You can get details on the text and the course on my website, which is profhugodegaris.wordpress.com. Click on the tab deGarisMPC, so M for mathematics, pure mathematics, P for physics, math physics, and about 10% of lectures, I guess, will be on C, which is computer theory. Right? Now, I can promise you this lecture, it's going to be a bit of the case of not seeing the wood for the trees. We'll be doing quite a few details in this session, but it won't become clear the motivation on why we're doing all these details and why we're talking about delta wells in the first place. Now, at this stage, we have a pretty good idea of what a well is, a potential well, like we had infinite potential wells. Yeah, just a minute. I was experimenting with the curtains open to get a bit more light, but I found it too distracting because there were cars going back and forth and it was distracting my brain. I need to concentrate, as you can imagine. So, we've already done infinite wells. We've done square wells, finite square wells, where the potential was finite, like V0. Now, in this session, we're going to describe a technique where we're still talking about wells, but with a special property, and this special property becomes extremely useful in future lectures. So in a sense, this lecture is preparatory, and it probably will not make a lot of sense to you until you have the hindsight gained by studying these future lectures. So you're just going to have to bear with me for a while, for a lecture or two. And wise, well, by the way, this particular chapter 3, was an addition to the second edition of the book. I don't know if you see it down here. Second edition, right? In the first edition of this book, there was no discussion of, well, as far as I know, no discussion of delta wells. Right? So this has been added simply because of it's very useful when analysing periodic structures in silicon and so forth. So applying quantum mechanics to these periodic structures in crystals and whatnot. So very useful for solid state physics and theory of telecommunications with circuitry and so forth. Right? So now this, about half of it, more or less, is familiar because it's just the square well. That's the general context. Still just the square well, and we can focus on the ground state of it. So it's just yet another STI. Schrödinger time-independent equation. So we have 4 chapters on this topic, right? Very broad topic. And towards the end, quite a bit of math. Well, it's just algebra, but useful to justify the use of this rather weird technique. Now, maybe a bit of a comment about delta wells. Why this word delta? Well, it's taken from Dirac's delta function, and it's a well which has properties similar to Dirac's delta function, Dirac's famous delta function. And in the previous session, towards the end, I gave a description of what a Dirac delta function is. it's basic. Just think of a delta function basically as a spike, right? You sort of nothing, right? Just a blip. So effectively, that function that looks like this, it's like an extremely steep hill, where the width of that function is effectively 0. Its height is effectively infinite, but such that as the width goes to nothing and the height goes to infinity, it does so in such a way that the total area under the spike, under that curve, is finite. Right? In Dirac's case, it's usually that area is usually 1. Now the potential well in this case, a delta well, is one where the depth of the well, the potential V0, goes to infinity. The width of the well, of order A, as that goes to 0, the product, in other words the area if you like, of that, the width A times the depth of the well, V0, so A times V0 remains finite. Right? So it's a special kind of well. It's called a delta well for obvious reasons, obvious to you now. But you still may say, well, so what? What's the point of introducing delta wells? What use are they? And I can't explain that to you yet. You just have to wait for a lecture or so. Okay. So like I say, this is just preparatory. Right. Now, before I get into the nitty-gritty, let me make some general comments. I suppose now you're getting used to the idea that the board is relatively more visible, thank God. It was my biggest problem. Thanks now to the idea of compressing high-definition filming. So I'm filming right now in high definition, and we'll later compress it and then send it off to YouTube. So I'm doing that routinely now. So I hope with greater visibility, more people will find these courses interesting, and that gets me speculating. I'm wondering how long it's going to take for the academic community in general, and there are something like ballpark, I don't know, maybe 10,000 universities in the world, and I'm just wondering now, how many years is it going to take before that community, all those hundreds of thousands, millions of people involved in teaching and researching, especially the teaching side, how long will it take them before they realize that their futures are, well, I'll speak bluntly, will be destroyed, right? Because what are they doing? They're earning their living by teaching. And why should students go to such professors and pay extremely high prices, like exorbitant prices? For example, the Ivy League schools in America, you can pay, the parents, the students tend not to, but the parents tend to pay $40,000, $50,000 a year for such tuition when the students could get it for free. So I'm very conscious that the sort of thing I'm doing is revolutionary. I realize that because as far as I know, I'm pioneering free proffing. Now, lots of professors, waged professors, so teaching in classrooms, they have people come in with camcorders and so forth and record their lectures, but they're still effectively waged professor lectures, right? They're still working within the traditional context of a classroom lecture. Whereas what I'm doing, I'm doing this in my bedroom, right? I mean, you can't see it, but between me and the camera is a double bed, right? I'm doing this for free at home, and the plan, of course, is to provide high level. So I'll go right up to PhD 2, second year level in math and physics. So to provide high level education for free, and I do that for lots of reasons. If you want to go into the philosophy behind that, have a look at my introductory video at before the first real lectures got started. All right. Okay, so think about the square well, not an infinite square well. So the depth of your potential is V naught. Okay, so we've done that kind of thing before, and let's talk about the even